All right, it's about 2 minutes after the hour. So I'm gonna do my best to keep this to just 1 hour. Those of you that are currently enrolled in our course, sometimes our live classes can go a little bit long. We try to squeeze all that good content in for the PE exam. So I am gonna do my best to try to keep this right to 1 hour. So we'll try to wrap right at 7 p.m. Eastern time for those of you on the East Coast like myself. I do have an open Q&A at the end. I'll try to answer as many questions as time permits. The practice problems we're going to be doing tonight, I'm going to be very selective with the questions, again, just to make sure I can really hold myself accountable for keeping everyone to that hour. All right, so I'm going to go ahead and make myself a little bit smaller here so we can see everything on the screen. Great. So we'll get started. So what is tonight about? So today, I'm happy to announce today is the book launch party for our brand new AIT only practice exam for the new CBT format for the Electrical Power PE exam. So I'm holding in my hands the very first printed author copy. It's 312 pages long, 2.5 years in the making. And if you stick around for the entire hour tonight, even though we technically are in the pre-launch phase, if you stick around, I'm going to tell you how you can grab this book right now completely at cost, at the lowest cost that Amazon will let me sell it. In other words, I'll make exactly $0 and you end up only paying for the shipping and printing costs, right? My goal is to get this book into as many hands as possible. So during our book launch phase, I'm going to keep it priced as low as possible. So if you hang out for the last hour, I'm going to show you exactly how you can get this in a day or two, get this exact copy in your hands. All right, you guys ready? So let's get started. Tonight's agenda, we're going to be talking about, number one, why on earth would I make an AIT only practice exam, right? That's the elephant in the room. So we're going to talk about AIT questions, why I decided to invest that time to make the practice exam. After that, I want to hear from everyone in the chat. We did a little bit of introductions right while we were getting started, but I'm going to do a student poll. I'll be asking each of you to answer in the chat. So that's you guys. Third, we're going to talk briefly about our class schedules for 2022. Fourth, that's what you're all in here for, right? We're going to solve some AIT practice problems together. I've got 3 practice problems ready to go straight from our brand new book. We're going to try out 3 this time. I'm planning on doing a couple more of these free live classes. So depending on how quickly we get through these 3, I might add some more in the future. But for the first one, we'll play it safe. We're going to solve 3 together. 5, the book launch party, right? I'm going to tell you how you can get this exact book, right? This is the first author copy. I'm the only one that has a printed copy right now. I was really excited to get my hands on it, see it in printed format. But I'm going to show you how you can get this delivered to your doorstep in a couple of days, exactly at cost. $0 to me. Literally, you're paying for printing and shipping. And then 6, we'll do an open Q&A again as time permits. I'm going to really try to stay to just 1 hour. And as a reminder, please, before we continue, take one moment in your chat settings where it says to. It should either say panelists and attendees, or it should say everyone. I just want to make sure, I don't want anyone to feel like they're being ignored. But if you're not on everyone, or it might say panelists and attendees, then only I'm going to be able to see your message, and you won't be able to interact with everyone else in the chat tonight. All right, you guys ready? Let's do a quick student poll. So how many of you are currently enrolled students? Type 1 on your keyboard out of curiosity. So of course, this is an absolutely free class open to current students, former students, people that are just curious. Out of curiosity, great. Got a lot of students in here tonight in the class. How's everyone liking that on-demand semester so far? How's everyone like that new student message board we've been playing around with? Really nice, right? Sharp, it's fast, a lot easier to get the questions answered. Adam said 100%, fantastic. Omer said he liked it, good. How about any former students, type 2? So maybe you enrolled in the past, you got this newsletter in your inbox, you said, hey, I want to see what Zach's up to. He's always coming out with great new content, exciting content. I want to see what he's got in store for us. Or maybe you're just, you want to continue working on your professional development. You want to take advantage of these learning opportunities as they pop up. Good. Let's see a lot of former students. Nahemis, Joseph, Yazzer, Tay, Omer, Will, Wilo, Chad, Andy, Andres, Arturo. Good to see you, Arturo. Steve, excellent. Good to see all of you again. All right. How about any new users maybe just signed up only on the free trial? Type 3. So maybe you're just enrolled on the free trial. You got added to our newsletter. You saw this pop up in your inbox and you maybe thought to yourself, hey, Zach's got a fantastic reputation online, obviously, for teaching the Power exam. I want to kind of get a taste of what it's like attending a live class. All right, good. Lots of threes here in the chat. Sarah Lewis. Is it Patixo, P-A-T-X, or Patix, P-A-T-X-I? Did I pronounce your name right? Reza, Ryan, Michelle, Issa, Samuel, Erica, Raul, Vic, Carlo. Great. Thank you so much for joining us. Hope you guys like this free class. Oh, by the way, I will be posting the recording to this on YouTube, so don't feel like you got to scramble. If you're not able to write everything down when we solve those problems, I will be posting this on YouTube. So you'll be able to watch this later. And I'm planning on doing at least 2 more of these while we promote the brand new book as well. All right, out of curiosity, are there any non-electrical engineers in the chat? Type 4 on your keyboard in the chat. And out of curiosity, let me know what type, what's your discipline? Maybe any civils, mechanicals, electronics. We do help quite a lot of civils, a lot of mechanical engineers that find themselves in the power industry for one reason or another. In the photovoltaic industry is a common one, building construction, maybe for energy audits. Great. Power electronics, said Lewis. And last, anyone else not described by the previous 4, either current students, former students, new users, non-electrical engineers, anyone else out of curiosity? Here's the back cover of that book right there. Nuclear, said Jose. Excellent. All right, so really quick, we're going to talk about the current semester schedules for our online class, and then we'll get right into solving those 3 practice problems together. We're making great time too, so I'm hopeful we'll be able to do a lot of Q&A at the end and still make it to 1 hour. All right, so every year, I'm going to scroll down to my notes here. Every year, I host 4 separate cohort-based semesters every year for the PE exam in Power. What's cohort meaning? That means you're going to move through our entire semester in one cohesive group. A lot of times when people take the PE exam, they kind of feel like they're on an island. They feel like they're taking the exam by themselves, studying by themselves, kind of like in a dungeon or in a cave, right? Our program, it's one of the most popular programs in the world for the PE exam. So when you're part of that cohort, we have the most engaged message board for the Power exam. I'm sure some of you have been on Reddit, maybe engineer boards, maybe some of the Facebook groups out there. It's nothing like our private message board. I hang out on there at least an hour or 2 a day answering questions. It's so engaged that typically by the time I get on there, questions have already been answered 4 or 5 times by other students. So it's a really powerful community. Again, just helps you feel like you're not alone. A lot of people make great professional relationships so that they even continue to carry on after our program. So based on those 4 semester cohorts, 2 of them are offered live in real time. Those are the winter and summer semesters. In between the live semesters, we have on-demand semesters that occur in the spring and fall. So right now, we're currently in the spring 2022 on-demand semester. The spring 2022 on-demand semester runs from May through July. Once that's done, we're going to start our next live class semester for the summer semester. That's going to run from July to October. And then again, followed by the last semester of the 2022 calendar year will be fall. Again, that'll be on demand from October to December. After that, in 2023, the months of these semesters go back to our normal scheduling. This year, we were a little delayed. Number one, I got married early January, as a few of you congratulated me in the chat when we first started. Thank you. And my wife and I took a 2-week honeymoon. So this semester, if you look at the semester months, it's kind of shifted by about a month or 2. So 2023, winter, the first semester of the year in quarter 1, will be from January to March. That's going to be a live class semester. Then in Q2, we'll have an on-demand semester for spring from April to July. In quarter 3 of 2023, again, we're going to rotate back to a live class semester from July to September. And then the last quarter of the year, quarter 4 for the fall season, it's going to be an on-demand semester from October to December. Now, really quick, I'm going to briefly show you, for those of you that are not currently enrolled, I'm going to show you the schedule for the current spring on-demand semester that we're in right now. And then let's look at the next semester too. After that, all of these schedules are available for download on our live class page. If you go to electricalpereview.com, if you click on the live courses, you'll be able to download each of these. This way, you'll be able to download each of these semester schedules to your computer. So let's see, today is Friday, June 3rd, right? So far for the spring 2022 on-demand semester, class 1, the introduction, we typically talk about strategy, best practices, how to use our program, how to take practice exams, general orientation, all that great stuff. That's already occurred for this semester. Live class 2, circuit analysis is done. Live class 3, transformers is done. Class 4, induction and synchronous machines is done. 5, devices and power electronics is done. And then right here next week will be live class number 6, of course, only offered on demand during the spring on demand semester. So it's going to be the class recording, but will be for class 6, power factor correction and power flow on Monday, June 6th, this coming Monday. After that, class 7, transmission lines, voltage drop, voltage regulation. Then class 8, per unit, fault current analysis, symmetrical components. Class 9, protection, everyone's favorite. Class 10, applications, and then class 11, the final class, the end of live class test. The spring 2022 on-demand semester, it's going to be ending on Sunday, July 17th. The day after the spring on-demand semester ends on Sunday, July 17th, the following live class semester for summer will be starting on Monday, July 18th. So live class semesters, we offer every single class live. We meet twice a week for about 3 hours, typically on Tuesdays and Wednesdays. And then during the on-demand semesters, I get a break. I get to work on new content like our brand new AIT practice exam here. And for monthly subscription plan students, the class recordings are dripped out once a week, similar to the schedule you're seeing in front of you. Or for unlimited package students, all of the classes are available all at once. All right, let's see. Any questions really quick on the semester schedules before we jump in? What everyone's waiting for, we'll start by solving our first AIT problem together. Oh, did I miss one more? Let's see. I think I actually missed a slide, didn't I? I'm going to jump right back. We didn't talk about. Is it missing? Here we go. I missed why make an AIT only practice exam. So we'll answer these first, then we'll jump into the practice problems. All right, any questions? Let's see, Tina said, so after June 17th, we lose access to all of the previous semester classes. Tina, it depends. The monthly subscription plan students will start over with the live semester. Unlimited package students always have access to last semester's live class recordings. So if you're an unlimited package student, nothing will change. You'll still have that entire archive. Monthly subscription plan students, it will update, and students are always rolling over. So it doesn't matter if you enrolled in the middle semester, we use a rolling enrollment system. So when one semester ends and a new one starts, all active students will automatically be rolled over into that next semester. Let's see, Fred said, do I need to email you to request to convert from the unlimited package to the on-demand? Yes, if you are a monthly subscription plan student, you'd like to upgrade to the unlimited package, just shoot me an email. All right. We'll back up here. I jumped a little too forward and I missed this slide. So we'll cover why on earth would I make an AIT only practice exam. We'll talk a little bit about AIT practice problems, what they are, and then we'll solve those problems together. All right, so AIT practice problems. What is an AIT question? Can anyone tell me in the chat? What's an AIT question? How about what does AIT stand for? Alternative information type. Excellent job, Anthony. Yeah, AIT stands for alternative information type. These are 4 brand new types of problems that you're going to see on the CBT format. So the original problem that you're probably used to the most is just standard old school multiple choice, right? A, B, C, or D. You can only select one answer. Now the new types of questions are multiple correct, point and click, drag and drop, and fill in the blank. Tonight, we've got a multiple choice first, then we've got a drag and the drop problem, and then we've got a fill in the blank problem. Now, again, why make an AIT only practice exam? If you've noticed, there really isn't a lot of material to study from when it comes to AIT practice problems until now, right? Until this book. So until now, I think there's about 4 in the official NCEES practice exam. Some other authors have a couple out there, but it's really hard to find AIT questions to study from. Has anyone here not taken the CBT format? Maybe you've only taken the paper and pencil type 1, or maybe you haven't taken the PE exam at all type 1. Yeah, so you might be seeing these AIT problems for the first time. AIT problems, you're only going to expect to see a handful of them during the exam. So you're not going to have an entire exam of AIT practice problems. The majority will be standard multiple choice, what you can expect based on what NCEES has said publicly. But this practice exam is going to be an excellent way to prepare you for those qualitative questions. So until now, it's really been hard to find those practice problems to study from. Now, I personally love AIT problems because they are extremely challenging. Old school multiple choice, if you just guess, you have what? 25% chance of guessing right? A, B, C, D, only 4 possible answer choices. With AIT problems, especially select all that apply, it's usually A, B, C, D, and E, and it's any combination of those choices that could be correct. Or maybe a drag and drop, same thing. You've got to drag, typically labels, you got to drag everything to the correct place. And there's no partial credit, right? Very challenging. They really thoroughly test your understanding of these subjects. Same thing, point and click. A lot of times interpreting graphs or diagrams, you got to be really familiar with that graph. You got to click the exact spot that you're asking you to click. And then fill in the blank. Rounding is really important, right? We got to figure out, you ever look at your neighbor's work and notice maybe you guys were off by a couple of decimal points, or even sometimes whole numbers. So fill in the blank, really important. Accuracy is really important on how to use your calculator properly to round and carry those values forward. I'm going to show you how to do that tonight on our third problem, is the fill in the blank problem. The reason why AIT practice problems are so fantastic for studying for the PE exam, it's like learning more than one problem at a time. So again, this book, 312 pages, 80 AIT practice problems, the size of the PE exam, all AIT problems. Working through this book and really understanding the solutions, it's like you're covering hundreds and hundreds of problems in the same time it takes to cover those 80. It's really, really going to develop your understanding just about all of the exam subjects. Most of all, it's going to really help shine a light on your current blind spots, right? If you can solve an easy problem, that doesn't really help you prepare for the PE exam, right? They're going to really test your understanding. They're going to ask you questions looking at perspectives that you haven't really considered before. So it's really important that we can, number one, identify our blind spots, and number two, learn from them, right? So that's the whole goal of the AIT practice exam, of course, is to help you pass the PE exam. All right. Now, so we've covered why an AIT practice exam. We've covered our semester schedules. We're 20 minutes in. We're making great time. We're going to go ahead and start by solving the first problem together. So go ahead, get a paper and pencil if you have one with you. We're going to take notes together. This one doesn't even require a calculator, so I'm going to keep the calculator off the screen for now. This is problem number 17 from the published version of our book. Now, if you're a current student, if you've got access to the PDF copy of the early release version, you've got 85 problems. We trimmed out 5 of them, and we changed the order a little bit. So if you're looking at the early release version, this number 17 won't match up with your 17, but this is in that one as well. And anyone, when you purchase the published copy, this will be problem 17 in the book. All right, problem 17 says, which of the following phasor diagrams represent a lagging synchronous machine? What kind of AIT problem is this? This is select all that apply. So it can be any combination of A, B, C, D, and or E to get it right. Now, phasor diagrams are challenging at first, especially when it comes to synchronous machines. We've got 2 different types of synchronous machines. We've got motors, we've got generators. We've got 2 voltages shown on the phasor diagram. We've got EO, which is the internally induced stator phase voltage. That's the voltage that's induced into the stator windings from the excited rotor. And then we have E is the terminal phase voltage. This is the voltage where that machine is connected to the power system. All right, anyone want to take a guess? A, B, C, D, and or E, which of these represent a lagging synchronous machine? Notice the problem didn't say synchronous generator, it didn't say synchronous motor, right? It could be either. So which of these phasor diagrams out of the 5 could be a lagging synchronous motor or a lagging synchronous generator? All right, I'm going to read some answers in the chat. I see a lot of you saying BCE from Jean-Marc, AU, George, B and E from John Van Sickle. Good to see you, John. Arturo says BCE. C from Steve. C and D from Victor Hart. A and E from Josh. Who else? Got a lot of B, C, and E's in here. Victor said B is not leading or lagging. Great observation, Victor. Right on the money. All right, let's work through this. So on the next page, I've got some sample phasor diagrams and circuits that's just going to help us answer this. Now, again, if you're already a student in our class, this is going to be just a brief review. We cover this in much more depth during our live class. So again, we're looking for a lagging synchronous machine, right? So I've got a phasor diagram and a circuit on the left side and on the right side. Who can tell me the circuit and the phasor diagram on the left, is that a motor or is that a generator? Does anyone want to take a guess at that? Is that a synchronous motor or a synchronous generator? Brian says motor, Alex says motor, anyone else? Anthony says motor, Nadia says motor, great. Everyone's saying motor. Yeah, it's a motor. How do we know? How do we know just by looking at it that that's a motor and not a generator? Here's my trick. Look at the direction of current flow. So current I is flowing from E, where the machine is connected to, that's the power supply or electrical system, and it's flowing into the stator windings, right? Those stator windings are drawing that current in from the power supply. Try that one more time. You guys hear me now? So current and real power is always going to flow from leading to lag. I lost my chat menu here. Where'd you guys go? All right, got you back up. So just like down here in the circuit, current I on the phasor diagram flows from the terminal voltage E to the induced stator voltage. All right, again, we want to know lagging machines. So when this kind of machine, a motor is lagging, is it overexcited or underexcited? Who can guess that in the chat? When a synchronous motor is lagging, is it over or underexcited? Steve says under, Samantha says under, Zaid says ideal, not quite. Good, yeah, just about everyone's saying what? Everyone's saying underexcited. All right, what are the conditions for an underexcited synchronous motor? First of all, if it's lagging, what's the relationship with the reactive power Q? If it's lagging, is it consuming or is it supplying reactive power Q? For a lagging power factor, we know it's got to be what? Yeah, it's got to be consuming. Good job, Alex. So Q, our reactive power, is being consumed. It's a lagging power factor motor. Now, on our answer choices, we have phasor diagrams for just the terminal voltage E and the induced voltage EO. So what's the relationship between these voltages for a lagging, underexcited synchronous motor? We can say the real component of the induced stator voltage EO is going to be smaller than the magnitude of the terminal voltage. If you're not familiar with that notation, if you're not a student in our class yet, don't worry. I know it looks a little foreign. I'm going to show you how we're going to use that relationship on the next page to analyze each of those 5 answer choices to see which ones are correct. All right, over here on the right, same exercise. Is this phasor diagram and is this circuit on the right, is this synchronous machine a motor or a generator? Number one, we could use process of elimination and say, well, we already know the other one was a motor, so it's got to be a generator. But let's not be lazy. Let's use that same trick as before that I showed you. Let's look at the direction of the current flow. This time, the current is flowing from what to what? This time, those stator windings are supplying the current to the connected power supply, right? It's got to be a what? It's got to be a generator. It's got to be a generator. The magnetic field in the stator that's being induced from the excited rotor is now supplying the current out of it to E, where that machine is connected to the power supply, the utility system, the electrical system, right? This is a generator. All right, let's look up here at this phasor diagram. Same thing. Current always flows from what to what? Who can tell me in the chat? It's going to flow from the leading voltage to the lagging voltage. This time the leading voltage is EO and the lagging voltage is E. Before, for the motor, the leading voltage was E and the lagging voltage was EO, right? This relationship has changed. Our electrical torque angle is now greater than 0, right? Where before it was negative, it was less than 0. So we know without a shadow of a doubt, this has to be a generator. All right, question number 2. When this type of machine is lagging, when a generator is lagging, is it overexcited or underexcited? Be really careful here. Here's a gotcha. Here's a little bit of a counterintuitive answer. Josh says overexcited. Anyone else? Any other brave souls out there? I know Josh is pretty brave. I know there's got to be other brave engineers out there. Nadia says overexcited. Scott says under. Kevin says over. Fred says over. Amar says over. Brian says under. Rule says under. Samantha says over. Joseph says over. So I'd say about 75% of us are saying overexcited and 25% of us are saying underexcited. All right, this time for a generator to be lagging, it's going to be overexcited. It's different now compared to our motor. Think about this. A lagging motor over here on the left, if our motor is lagging and it's requiring VARs, requiring reactive power, what kind of generator do I need to supply a lagging motor? I also need a lagging generator. That's the gotcha. That's the hardest part. It's a little counterintuitive the first time you learn this. And a lagging power factor load needs and requires a lagging power factor power supply, right? It's got to be in equilibrium. So a lagging generator is actually overexcited. All right, what is the relationship or the conditions for reactive power for a lagging overexcited generator? If the motor was consuming reactive power, now, yeah, good job, Kevin. Now reactive power is being supplied. Reactive power is being supplied, right? Lagging motor pulls reactive power from the power system. A lagging generator pushes or supplies that reactive power to the power system so that the motor can consume it, right? I think it's like tug of war. Lagging motor pulls the VARs, lagging generator pushes the VARs, right? It's one big equilibrium game of tug of war. All right, just like before, what's the relationship with the real component of our induced voltage EO compared to the magnitude of the terminal voltage E? Now what? Is it less than the magnitude of E like a motor? Or is it greater? Is it going to be greater then? It's going to be greater. Now the real component EO is greater than magnitude E for an overexcited machine. Now, really quick, an overexcited machine, if it's a motor or a generator, this is always true. The real component of EO is greater than E, and Q is being supplied. An underexcited synchronous machine, whether or not it's a motor or a generator, Q is being consumed, and the real component of EO is smaller than E. So those are true regardless of if it's a motor or a generator, right? Where it changes is your lagging versus leading power factor in relation to the excitation, right? Now we've got a lagging motor, underexcited, lagging generator, overexcited. All right, if you're looking for more information, this is covered on page 50 to 51 of the latest version of the reference handbook. And if you're a current student, this is all covered in much more detail on class 4 is induction and synchronous machines. All right, so let's use what we just learned and apply it to each of those 5 possible answer choices, A, B, C, D, and or E. Remember, it's not multiple choice. It's what? Select all that apply. So any of these 5 answer choices could potentially be a right answer. All right, so we've got motors and generators on here. What kind of motor are we looking for a lagging synchronous motor? Is it under or overexcited for the motor? In order to be lagging, a motor has to have what kind of excitation? Yeah, under excitation. Great job, Brian and Alex. So we're looking for any underexcited motors. And how about for generator? What's the condition, the excitation condition for a generator, again, for it to be lagging? It's not underexcited anymore. Now it's what? Yeah, overexcited. Good job, John and Joseph. So we're looking for any overexcited generators. So we've got 5 possible phasor diagrams. Some are motors, some are generators. We got to look for the motors that are underexcited and the generators that are overexcited. Let's try A. Is the phasor diagram in A, is this a motor or a generator? What direction is the current flowing from? From leading to lagging, it's flowing from the stator windings to the connected power supply. This is what? Yeah, it's a generator. Good job, JP. This is a generator. All right, we're going to compare the real component of our induced voltage, EO, to the terminal voltage, E. That relationship, here's how we figure it out looking at the phasor diagram. Super easy. Ready for this? Find your induced voltage, draw a straight line down to the horizontal axis. Congratulations, you just determined the real component of EO. So this red line from the origin all the way out to here, that's the real component of EO. What's real component? It's just the horizontal leg of the triangle that EO makes. All right, is that bigger? Is this red arrow bigger or smaller than this black arrow of the terminal voltage E? Is it bigger or smaller? It's bigger, right? Look, the real component starts at the origin and it extends past E. Is this an answer? Is this a lagging motor? I'm sorry, is this a lagging generator? Sure is, right? It's overexcited. This is an overexcited lagging generator, right? It's lagging. It's overexcited. All right, B. Is this a motor or a generator? What's the direction of my current flow? Current flows from leading to lagging. This time it's flowing from the terminal connection, right? Where that machine connects to the power supply to the stator windings, right? The stator windings EO, they're drawing that current in. It's got to be a load. It's a motor, right? B is a motor. In order for a motor to lag, it's got to be what? It's got to be underexcited. Let's figure out if this motor is underexcited. Let's use that same trick. Find EO. Draw a straight line to E. And now we just found the real component of EO. How does the real component of EO compare to the magnitude of E in this example? Is it bigger, smaller, or yeah, it's equal? Good job, Mark, Anthony, Lewis. Yeah, it's equal. So this motor is neither leading nor lagging. It's neither overexcited nor underexcited. If a load is not leading and it's not lagging, it can only be what? Good job, Kevin. Kevin said in the chat, power factor equals 1. It's got a unity power factor. That synchronous motor in this phasor diagram, it's creating the exact amount of reactive power that it needs to satisfy the magnetic field requirements of its stator windings. It's kind of like a self-contained motor. right? Compare that to a plain old induction motor that's going to draw that reactive power from the power supply. The synchronous machine is going to create its own magnetic field from its own reactive power supply. And it's only creating the exact amount of reactive power it needs. So it has a unity power factor. So is this motor leading? No. Is it lagging? No. So B is not going to be the answer choice, right? This motor is not lagging. Starting to click for everybody? All right, C. Who can tell me, is C a generator or a motor? A C a generator or motor? Good job, Samantha. Samantha said it's a motor. You got it. C is a motor. If a motor is lagging, it's got to be what? It's got to be underexcited. So let's find the real component of EO. Draw that straight line to the origin, and then draw your new flat line. This red arrow is the real component of EO, right? It's the base of the triangle. All right, let me know in the chat, what is the relationship for answer choice C when we compare the real component of EO to the magnitude of E? Is it bigger or smaller or the same? It's bigger, right? Yeah, this means it's overexcited, not underexcited, right? What is this, a leading or lagging power factor motor? Is this leading or lagging? Yeah, this is a leading power factor overexcited motor. We're interested in lagging machines. So C is also not correct. All right, D, is this a motor or a generator? Is everyone getting comfortable recognizing right away motors or generators? Lewis said it's a generator. Good job, Lewis. How do we know that this is a generator? Current is flowing from EO, the stator, to the terminal E, right? It's a generator. All right, let's figure out the excitation conditions of the machine. Here's our straight line from EO. It's hard to see it, but here is there we go. Here's the real component. What's the relationship again of the real component of the induced stator windings, EO, compared to the magnitude of our terminal voltage E? Bigger, smaller, or is it the same like choice B? Smaller, says Rule. Smaller. Yep, this is a leading generator. Great job, Anthony. This is a leading under-excited generator. Are we looking for leading generators? No, right? We're looking for lagging. So D is also not correct. All right, last one. You guys ready? Let's do E. Is E a motor or a generator? It's a motor. Current is flowing from E, the terminal, to EO, the stator. The stator's drawing that current in. All right, let's check out the excitation. Find EO. Draw our straight line, and then use that to draw the real component. There's the real component of EO. What's the relationship when we compare the real component of EO to the magnitude of the terminal voltage? It's smaller. So Anthony says real component of EO is smaller than the magnitude of E. That is an underexcited lagging motor. Excellent job, Anthony. This is an underexcited lagging synchronous motor, right? E is what? E is also correct. So out of A, B, C, and or D, we have two synchronous machines that are lagging. A on the top left is a lagging synchronous generator that's overexcited, pushing those VARs, pushing that reactive power. E is an underexcited lagging motor, pulling that reactive power, pulling it in, consuming VARs. So the answer is A and E. All right, great. Good job so far, everyone. It's 6:40. I'm going to go ahead and move on to the next problem. The next two are a lot quicker. Again, I'm trying to keep myself just to 1 hour. All of my students know I like to push it. So I'm going to try to keep myself to 1 hour. I'm going to hold myself accountable. So that was an example of a multiple correct. Did you see how we had to evaluate each and every answer choice? Any combination, it could have just been A. We don't know until we got all the way to E, but it was A and E. There's no partial credit for these problems. Very no partial credit. They're tough, right? They're tough. Look at this. Even though this was one problem, we really evaluated 1, 2, 3, 4, 5 different conditions. It's like we just worked 5 phasor diagram problems. All right, next problem. Problem 20. So problem 20 is going to be a drag and drop problem, AIT problem. Problem 20 says, below are 4 different types of circuit diagrams that belong to the same system. Match the correct label. Here's our labels down here. Match the correct label for each circuit diagram by dragging each label to its appropriate choice. Let's look at our answer choices. From left to right, we've got negative sequence network, positive sequence network, zero sequence network, or single line diagram. Symmetrical components, right? Everyone's least favorite topic on the PE exam. Symmetrical components is complicated. All right, the easiest one to pick out is what? Out of those 4 diagrams, what's the easiest one that jumps out? It's different than the others. Single line diagram. Yeah, which one's a single line diagram? Which one's a single line diagram? Top right, right? So, okay, there's one. I'm going to grab my single line diagram. Boom. Single line diagram is done. How do I know it's a single line diagram? It looks just like every other single line diagram schematic I've ever looked at, right? Very easy to recognize for an electrical engineer. All right, how do we go from a single line diagram to a positive sequence network? How do we go from a single line diagram to a positive sequence network? What do? We include the voltage source and we use the positive sequence impedance or reactance values. Only 3 of the remaining circuits has a voltage source. Which one is it? It's the bottom left. Bottom left is the positive sequence network. So here's the generator single phase terminal voltage, right? E for terminal for this generator. This is going to be the generator's positive sequence reactance. This is the transformer's positive sequence reactance. This is the motor's positive sequence reactance, right? We use superscript 1 for positive sequence. So positive sequence is done. How do we go from the positive sequence network to the negative sequence network? What do? We short circuit what? Remove the source, says Johnny. Yeah, we're not only going to remove the source, we're going to short circuit it. We're going to short circuit it, and we're going to replace the positive sequence reactances or impedances with the negative sequence values. Nothing else changes. Out of the remaining 2 circuits, this one changes. I got a big open circuit here. That's not right. So over here on the right is the negative sequence network. Here's the short-circuited voltage source. I'm going to just draw a straight line, right? That's the terminal voltage shorted out. And now we've got the generator's negative sequence reactance, the transformer's negative sequence reactance, and the motor's negative sequence reactance. This is the negative sequence network. All right. A lot of people are unfamiliar, uncomfortable, and just not, don't have a lot of exposure to zero sequence networks. Even if you don't know the slightest thing about zero sequence networks, could I solve this correctly with what I've just done so far? Could I do process of elimination? I could. I could say, I've got the single line diagram, the positive sequence network, and the negative sequence network. I know this has to be the zero sequence network. But how can we be sure? How do we go from a negative sequence network to a zero sequence network? First, instead of the superscript 2 for negative sequence, we use the superscript 0. We use the zero sequence reactances, right? Then any delta or Y connections are going to change the connection to the reference bus. So first, let's look at this generator. What's the grounding relationship of this generator? This is a Y solid grounded generator. A solid grounded generator, the grounding is short-circuited to the reference bus. So this short circuit right here, this is the solid generator connection to ground right here. Next, I've got the generator's zero sequence reactance, right? Here's this transformer. On the transformer, I have a delta Y grounded transformer. It's the most common transformer. On a zero sequence circuit, the delta side is open circuited and the Y grounded side is shorted to the reference bus before connecting to the transformer zero sequence impedance. So this right here that I'm bubbling, this is all due to the delta Y grounded transformer right here. All right, last, we made it through the transformer. I've got a motor, but the motor also has a ground. What kind of ground is this? It might be hard to see, but there's an inductor and it says X ground. This is a reactance grounded motor. See that? Reactance X. There's an inductor connected between the neutral and ground for that motor. What happens if I have a ground impedance or a ground reactance? What happens on the reference bus? Or I'm sorry, what happens on the zero sequence network rather? I'm going to take that value X ground, right? Whatever the reactance is right here, but I got to multiply it by something before I stick it on my zero sequence network. Anyone know? Yeah, multiply it by 3. Great job, Victor. And is it EGNON, EGNON? Did I say that correct? Yeah, we got to multiply this value by 3. This right here, that's the motor X ground, the reactance ground for that motor. And then last, we have the motor zero sequence reactance. And that is our single line diagram, our positive sequence network on the bottom left, negative sequence network on the bottom right, and zero sequence network on the upper left. If you're looking for more information here, this is included on page 69 and 70 of the latest NCEES reference handbook. And then we cover this in extreme detail during class number 8, which is the per unit system. It's fault analysis. And we cover symmetrical components. All right, last one. Don't worry, I know I do see some questions. I'm sorry, I'm going to be selective because we got 10 minutes left. But we will make it through. John said, thanks for tying the reference handbook. You are most welcome, John. All right, last problem. You guys ready to go? I'm going to wake up my calculator for this. This is the same style calculator. It might look a little different, but it's the same style calculator as the approved Texas Instrument calculator. All right, this is 44 in the new published copy of the AIT Practice Exam. 44 says a single phase, 112 kVA, 15,000 to 600 volt transformer is shorted on the low voltage side during a short circuit test with all measurements taken on the high voltage side. Here's our short circuit test data, the short circuit voltage, current, and power in the center. Then the problem says down here says the percent impedance of the transformer rounded to just 1 decimal place is blank. It says fill in your response. So this is a fill in the blank AIT practice problem. We're going to use our calculator to do all the heavy lifting. As I like to say, we're going to carry all of our values to the very end. And then we're going to use the final value to round for accuracy purposes. All right, how do we solve this? First thing I'm going to do is I'm going to fill in the short circuit test for the transformer. What's the short circuit voltage in the table? 500 volts. Next, what's the short circuit current that was measured? 7.1 amps. And last, what was the short circuit power? I don't know if I need this yet or not. I'm going to write it down anyways. P short circuit equals 1,200. Is everyone there? Did I lose you? I think I'm pushing the, I think my computer is screaming down here. It's running a little hot. Let me pull up the chat. Sorry about that. This is our first time live streaming like this on camera. So we're fixing the plane as we fly it. We're figuring out how to do this while we go along. All right, so we've got in the transformer short circuit test. Step number 1, if I want to find the percent impedance, what is percent impedance? It's really what? It's really the per unit impedance. Here's my transformer winding impedance. I can say complex Z equals R plus J XEQ. Here's polar form. Can I represent this? I'm sorry, here's rectangular form. Can I represent this in polar form as magnitude Z angle theta Z? Yeah, sure can. So if I can figure out magnitude Z, I can eventually get to my per unit impedance. So what about Ohm's law? Let's say step A, we're going to use Ohm's law, right? V equals IZ. Let's solve for Z. I'm going to say magnitude Z equals the magnitude of the voltage divided by the magnitude of the current. What's the magnitude? I'm going to zoom in here a little bit. What's the magnitude of the voltage? 500 volts, right? So I've got 500 volts on top. What's the magnitude of the current? I've got 7.1 amps on bottom. All right, in my calculator, I've got 500 over 7.1. We have a magnitude of 70.4 ohms for the magnitude of the impedance. I've got the magnitude of the impedance in the unit of ohms. How do I go from ohms to a value in the per unit system? I got to divide by what? I got to divide by the base impedance to get my impedance in per unit. All right, I can find the base impedance. ZB is the square of the voltage base divided by the power base. Where do we get these values from? Let's go back to the problem. Look at this. Here's the ratings of our transformer, right? 112 kVA, 15,000 to 600 volts, right? The rated values of a machine are the base values that are used to express its percent impedance value in. So here's our base values. I have 2 different voltage options to choose from. How do I know which voltage to use for the square of my base voltage? What side were the measurements taken on? What side? Yeah, this is not a red herring. We need this to solve the problem. The measurements are all taken on the high voltage side. Which is the high voltage? 15,000 or 600? 15,000, right? 15 kV. So I'm going to use 15 kV squared for our base voltage. And then our power is just 112 kVA, right? 112 kVA, the power rating of this transformer. All right, I'm going to do this in my calculator. So back over here on the left on my calculator, I've got fraction sign, 15 e to the 3 squared, don't forget to square it, divided by 112 e to the 3. So we've got a base impedance of 2008. I'm going to say 0.9 ohms, right? That is the base impedance. All right, last step. I've got my impedance in ohms and my base impedance in ohms. How do I find Z per unit? I'm going to divide my impedance value by my base value, right? I'm going to divide right here, 70.4 ohms. That's the magnitude right here. That's the magnitude of the transformer series winding impedance. I'm going to divide it by the base impedance, 2008.9 ohms. All right, now here's the thing. Here's where the fill in the blank problem gets tricky. Got to be as accurate as possible. We don't know the margin of error or the tolerance that they're going to accept. So I'm going to go in my calculator. I'm going to scroll up, pressing the up button until the 70.4 amps is highlighted. I press enter to bring it back down. I'm going to hit the divide button, and then I can either do second answer, not pi, or I can scroll up. Let me delete that pi. Or I can scroll up, grab the base impedance value by pressing enter when it's highlighted. Ta-da! We just use our calculator to do the heavy lifting for us without having to type in just 70.4, just 2008.9 for full accuracy. So the per unit impedance is 0.035. And then remember, we don't want it in per unit form. We want it in percent impedance. How do I go from a decimal to a percentage? How do I convert really quick? I'm going to multiply by what in the calculator? Yeah, multiply by 100. Good job, Adam and JP. Yeah, just multiply by 100. So back in my calculator, I'm going to say times 100. And it's automatically going to multiply that last value by 100 for me. So we get 3.5%. Or we could have taken our decimal point and moved it over once and twice to get that same 3.5%. So the percent impedance of that transformer rounded to one decimal point is 3.5% for your fill in the blank AIT problem. Now, where do you find this in the reference handbook? Page 63 is your short circuit test for transformers. Page 34 is the per unit system. And for us, if you're a student, class 3, we cover transformers in extreme detail. And then class 8, we cover the per unit system. All right, 6:59 p.m. I got all 3 problems done just under the hour. We're going to go ahead and I'm going to show you where to grab that book right now on sale. And then I'll stick around. We can run this a little longer. I'm happy to answer any questions in the chat, including any of the 3 problems that we did tonight. Does that sound good to everybody? And how did you guys like those AIT problems? Or was it a good mix, a little challenging, not too long? Good. JP liked it. Johnny, Joseph, Zaid, Fred said awesome. Great. All right. So, so that we're staying on time, like I promised we would, here's how you can grab the brand new practice exam right here. I've got the only copy that's ever been printed yet. Even though we're technically in the pre-launch phase, don't tell anybody. The problem is actually, or the book, it is live and published on Amazon. All you got to do is go to Amazon.com, type in my name. Don't forget PE. If you type in just Zach Stone, I guess there was an MTV show called Zach Stone is going to be famous about 10 or 20 years ago. So if you just type in Zach Stone, you'll find DVDs of a really cringy MTV TV show. So type in Zach Stone PE. You'll see the books pop up. And here it is. Here's the brand new AIT practice exam. So look at that. Look at the price. $20.14. This is literally at cost. I get 0 profit dollars for this sale. It is the absolute lowest price that Amazon will let me enter it in. At that price, you pay only for printing and shipping. And right now, again, I quietly published it about a week ago. I didn't tell anybody. Now they're ready to ship them. You can get it right now and it's shipped to your doorstep in just 2 days. That's it. So here is the AIT only practice exam. It took 2.5 years to make, 312 pages. If any of you guys have worked through my other practice exam, you know my practice exams are the most detailed rich solutions. It doesn't matter if you're stuck on a problem. It doesn't matter where you're stuck. Each solution painstakingly handholds you through every single step with visuals, demonstrations, examples. You'll often find that as you have a question while you're working through the solution's going to answer it for you as soon as you have that question. really guides you through every single step of the problem. I'm going to try this. I might be pushing the limits of my computer here. I don't want to lose you guys again. Let's see if I open up. Here we go. Let's try this. You guys see the web browser behind me? Good. Yeah, all you got to do, it's live right now. Type in Zach Stone PE, hit enter, and the first result is the brand new practice exam. So you click it, and there it is. Buy new, $20.14. Today's Friday, June 3rd. This tells me if I grab it right now, it'd be delivered Monday, June 6th, be at my doorstep Monday. So this is actually live on Amazon right now. I'm not sure how long I'm going to keep it at this price. My plan is to do 1 or 2 more of these free AIT webinars. I might bump it up during that time. I might bump it up after. Honestly, I don't know. It just depends on the demand. But really, the biggest goal is I want to get this in as many hands as possible. Oh, and I did see in the chat, those of you that are asking, let's get nice and big here on the screen. Those of you that are asking about, is it included with enrollment? Yes. The PDF version currently is included with enrollment for both the brand new AIT practice exam and our existing practice exam. We are about to republish this updated for the CBT format here in about a week or 2. But both practice exams are included with enrollment in PDF format. And we're also looking at in the future, we're going to incorporate some different software so you can actually take it just like the CBT format as well. That'll probably happen by about the end of the year. All right, 4 minutes after. I can't believe I made it. I was worried this was going to go about 30 minutes over. So how'd you guys like it? Give me some feedback. Did you like the AIT problems? I did see some feedback in the chat that the screen was a little bit blurry. Thanks for letting me know. I will check into that. Again, this is the first time I've been able to live stream like this with everything on screen. So it's definitely kind of pushing the limits. I've got a high powered computer for this. It's definitely pushing the limits of that. But I will be checking those settings to make sure that next time it is high quality, making sure that the recording is in high quality too. So I do appreciate you letting me know. Let's see, what else? Great, says Lewis. Great session, says Fred. Great. What else? You guys like it? Any questions? What about? Any questions? Any questions? Anthony said, how do AIT questions affect the 3-pass strategy? Great. Yeah, great question. I'm going to just move myself. Let's see if I can get here in the middle. There we go. Yeah, so if you're familiar with that strategy, I recommend typically you want to take the PE exam in 3 passes. Easy questions, medium questions, hard questions, regardless of what order they appear in. In other words, if the first question on the exam is the hardest question they got, you don't want to be wasting a ton of time on it. Just flag it, move on, come back to it. Anthony, same strategy applies. If you're comfortable solving it, knock it out. If you start solving it and you start kind of running in circles or you're not sure, skip it and move on. I would treat it like any other problem in that regard. If you've got maybe a select all that apply AIT question, and you're just spending way too much time on it, there's nothing wrong with skipping it and waiting for the next pass. As far as I know, as far as what NCEES has stated publicly, AIT questions are worth the same number of points as any other problem. So if you're wasting time solving it, just move on. What else? Any other questions? What else we got? What else? Erica said, for the unlimited subscription, are there practice problems different from your published practice exam? Erica, yes. In both of our paid enrollment options, monthly subscription and the unlimited package, you've got about 300 or 400 problems in the on-demand review course. You've got hundreds and hundreds of problems during live class that are different from the on-demand review course, exercises that I take you through live, just like we did today, homework questions that we review after the fact. And then on top of that, you've got our practice exams, and they're all different problems. So hundreds and hundreds and hundreds of problems. And on top of that, there's several hundred short and sweet videos, 15 minutes long, going through each problem type. And those are separate problems too. So most people find that they don't have enough time to work on outside material. And the vast majority of our students only use our program to pass. So we definitely have the largest, most comprehensive online class and program to study from. Definitely keep you busy for a while. What else? Jody Welch said, where can we find this in the online course? Jody, I'm currently stashing the PDF. It's the early released version. It actually has 5 more problems. That's 85 total. Jody, go to the live class course. There's nothing really there right now because we use that during live semesters. But if you go there, you'll be able to find and grab that PDF. There's still a couple of errors in that one that we corrected before the published copy, and I'll likely be replacing that in the future with the published version. But for all intents and purposes, it's the same exam. It's the same one. It's just missing all the text pages in the front and the back. What else? James said, do you have an FE class? Sure do. We've got a 100% free FE review course on our sister website. So our main website, electricalpereview.com. Our FE program is Electrical FE Review.com. Where we add content to it every couple of weeks, and it's 100% free, and we'll likely always keep it free. Great question. Anyone else? Any other questions? Let's see. Ask about the code books for the new CBT format. Yeah, when you take the new test in CBT format on your exam computer, they split your monitor down the middle. On one side is the CBT test. On the other side is all the reference books, code books, in digital format. What else? Issa said, are your live classes recorded? Yep, absolutely. Our live classes are recorded. Some students, they only like to watch the recording. You can speed up the recording so they're faster to get through. I always recommend attending live. You get to interact with a live chat just like you're doing now. Yeah, absolutely. All of our classes are recorded, and there's unlimited replays during the semester. So what else? Alex, good question. Alex said, for fill in the blank AIT, is it better to use conversion factors from the reference book instead of the unit conversion in your calculator? Yes, I 100% recommend using the unit conversions on, I believe it's page 2 of the reference handbook for fill in the blank. That's the information they're giving you. So to be within their accuracy, use those conversions. A big one is like the watts and horsepower conversion. They include a decimal on that, use it. Good question, Alex. Mark said, Casio calculator okay, or do you recommend TI? I personally recommend the TI. I teach with the TI. Most people find the TI more comfortable because they're familiar with it. They both do the same thing. I find the TI a little more intuitive. It's personal choice. If you're not sure, buy both. They're about 20 bucks on Amazon. I recommend bringing 2 calculators anyways for the PE exam in case one fails somehow, right? At the end of the day, it's your choice. They both do the same thing. What else? Any other questions? What'd I miss? 7:10 here. We are going strong. What else? Yeah, so students that are asking, where can you find the PDF version? It's currently located in the live class course. So if you go to your student dashboard when you're rolled in, if you click on live class, again, all the class recordings won't be there because we're in the on-demand semester. The class recordings will be in the respective on-demand course, but you will be able to find the current PDF version of the practice exam of the new one. It's not the final published version, but that kind of actually works out more in your favor because there's 5 more problems in the unpublished version that we trimmed out. And it's just missing some of the beginning like strategy pages, but for the most part, it's the same exact book. Johnny said we'd be sending out invites again for the upcoming AIT practice webinars. Yep, you betcha. Same way. So just keep an eye out on your inbox. Was that easy for you to register for? I know a few people had trouble. They were trying to use the electrical PE review student info, but you had to sign up for a Zoom account first. Not bad, said John. Good. Good. All right. Any other questions before we sign off for tonight? Hopefully the entire recording got captured, but there might have been a hiccup. It looked like Zoom restarted once or twice. So fingers crossed. We were going to post this on our YouTube channel. A lot of good content. So I really hope it captured it okay. All right, John said, interesting. Some government computers block Zoom. Interesting. All right, well, that is it for tonight. We're about 12 minutes after the hour, so we wrapped just about 1 hour like I promised. Again, thank you everyone for joining. I hope you like the free one, whether you're a current student, former student, whether you just signed up for the free trial and you're still figuring out what class and review course to attend. Again, the plan is to do at least 2 more of these, especially now I kind of got the kinks out. Do you guys like me being on screen? Do you find that more engaging? Typically live class, I'm not on screen just so it's easier to focus on the content. I know seeing a human being, especially when we're meeting remote, it's a lot more engaging. So I'm going to try to continue to do this. Again, I just got to figure out the quirks with the computer to make sure that it doesn't shut down again, but it's definitely pushed it to the limit. All right. If you have any questions, feel free to email me. Just about everyone in here, you should definitely have my email address if you were able to register for that webinar. So if you do have a question, you can respond directly to the original email that had the link to sign up. That was from me. Happy to answer any questions. And again, hope to see you on the next upcoming live class. I'm going to try to do probably another one. We'll probably do about one a week. I might stick to Friday. A lot of people said Tuesdays were good for them too. So we'll see, but I'll definitely let you know with enough time that you can register and plan accordingly. All right, everybody, hope you enjoyed, and we will see you next time. Good night.